So we'll now proceed with next topic on coding and artificial intelligence. And this will be actually presented by Mr. Yashil Seebun from Ceridian. So Mr. Seebun, good morning. Are you here?
Yes, good morning. I couldn't unmute myself, so it looks like the access was granted right now. So good morning, everyone. Happy to be here.
Good morning and welcome. So you may start to share your screen for your presentation.
Okay, perfect. Let's get started.
Great.
Okay, can everyone see my screen?
Yes, perfectly. You may proceed. Thank you.
Great. So welcome everyone to this little chat on programming and artificial intelligence. So this is what we're going to cover today. Short introduction on what this entire field is about. We'll zoom in a bit on programming, move on to artificial intelligence, and then, if you have any questions, you may ask them. If you have any questions while I'm talking, please type those out in the chat. So when we reach the conclusion, we can go over them in detail. All right, so let's dive into it. Firstly, a bit about myself. Technology is a long-standing passion of mine. I'm currently a manager of product and technology in the integration department at Ceridian. I have over 10 years of international experience across the software development field and managing various teams. I've worked in the banking, public sector, and cloud-based software development. So it's across quite a few fields I've had the chance to work with and with really great people. And yeah, I mean, technology, you can't say you like computers and not like video games, right? So that's something about me. Now, naturally, with regards to these fields that we're about to discuss, these are things that I do at my job as well. Programming, Ceridian, my current employer, is a major provider of human capital management software. So we make sure people get paid on time and everything about their work life is handled by our system. That's much harder than it looks, as it said here. So the core product here is Dayforce, and it works across a bunch of platforms. So again, it's a very complex solution, desktop and mobile. And when it comes to AI itself, these are things that Ceridian is building as well. We have things which assist with checking performance of employees through talent intelligence, and we also have AI voice assistants. So even in the day-to-day, these are things that these topics do affect my day-to-day, and I think that's something I want to share with you. Now, the topic of programming and AI, many people might think that, okay, this either doesn't concern me or it's something that, why would I bother? Somebody else will take care of it for me. But I would like you to think about one thing. Literally everywhere you look, these two fields are already affecting you. If you want to navigate the world, you can't use a mobile phone today without having at least some information technology skill. It's even reached the point where, I would say that it's as important as reading and writing if you want to work and communicate in today's world. This is something you can't skip. I believe all of us must have at least some family members, or even, some of you might be uncomfortable going into more advanced options on your phone or going beyond the basics of what your devices can do, simply out of being uncomfortable with the technology. And that's something which, as you've seen, when you get into the professional world, that's not going to work. You can't be uncomfortable using your work tool. You have to be good at it. And this is where information technology skills such as programming and AI do come in handy. Now, obviously, we just mentioned jobs. There are many career opportunities in this field. It keeps growing. And even in unrelated fields, it can make you more effective. In fact, I've seen, entrepreneurs of companies that have nothing to do with IT, like they don't have a knowledge of IT, and then they really struggle securing their businesses and what they do daily due to insufficient IT skills. Now, again, with these skills, you can build the future. But let's take a look a bit at the present as well. The pandemic, which right now seems to be waning a bit, which is a good thing, but it has forever changed the world. We are now in a remote first world in many places, and that's going to stay. That's not something that's going to disappear now. People in the workforce have seen the advantages, and it's important to actually be able to effectively use your information technology tools, which you won't fully understand unless you understand programming and AI, especially with the features, AI-assisted features you have now. And you want to be effective at what you do. So that covers already everything that we've talked about before, but also to be effective at what you do, you have to enjoy what you do. And the great thing about computing is that it's something really fun. Don't let how complex it may seem get in the way of what you can achieve with it. We've all learned how to walk and run, right? Like that looked very complex for us at a time when we can't remember it. The same thing applies to reading and writing. The same thing applies to how you use your devices. So there's value in this. Now, let's move on to what programming is. Okay, so computers in today's world, they do so much. And just look at what happens in 1 minute of the internet. Right now, the stats for this infographic have not been updated to 2022, but 2021 was already a very busy year, as you can see. Every minute, 500 hours of content uploaded on YouTube. 21.1 million people are wasting their time sending messages to each other. 1.4 million people are scrolling through Facebook, whether they are learning something or, again, not doing anything useful. It doesn't matter. It's 1.4 million people doing it. On Netflix, there are 28,000 people watching something or the other. And all that's in 1 minute. You can look at the other stats here, like the millions of dollars being spent and, messages being sent and all that stuff. So it's a very, very busy time on these platforms. And these are powered by computers, right? Now, let's put that into perspective. Your smartphone right now, even the weakest, is at least 1,000 times faster and has 10 million times more memory than the Apollo guidance computer, which landed people on the moon. And on that device, it's not just a moon landing device anymore. It's something that you can actually play games on, you can do your homework on, and you can literally run $1 million companies on that. So computers today, there's no question that they're very powerful. I just like to think about, okay, you can have something that can land something on the moon. What are you actually doing with it? Let's hold that thought for a moment. The thing is, however powerful the computer is, it seems intelligent, but it's not. You need to tell them exactly what to do. It will only ever do what it is instructed to do. So as you can see on the right-hand side here, a computer just takes input, applies some processing to it, and then provides an output. So what you tell that processor to do is what the computer will tell you. There's no actual thought in there, even when it comes to AI. We'll cover that in a moment. But the actual true thinking aspect of any problem is in humans. Computers don't have that today. However, it has become quite convincing to simulate it with the techniques we have today. For example, the Google Assistant and Siri and all those systems, they seem intelligent. Even a video game today, when you look at the behavior of enemies in a game, right? They advance very convincingly. However, none of that is truly intelligent. It's just programs that you've written. So humans are doing a lot of work to make computers seem intelligent today, just to save other humans more work, right? So it helps. Now, obviously, when it comes to augmentation by pattern detection, that is what basically AI is today. There are a lot of patterns it can detect now. It can match those patterns, and then it makes the program seem more intelligent. So there's augmentation through that. That's an additional technique that came in the last couple of years. And ultimately, all of this is possible through programming, which is simply the act of writing instructions for a computer to fulfill a purpose. All right. So remember this point. What are you doing with computers in your life? Well, you can, make it do what you want. Now, how exactly would you go about writing a program? This is a standard process. It's called the software development lifecycle. It's the base blueprint for all software development today. It looks long and complicated. It's not. You can actually solve any problem with it. In fact, it all starts off with you need to plan your work ahead of time. If you don't plan, you're planning to fail, basically. That's something universal. You need to analyze the problem that you have. Okay. Planning the work means you set out, okay, I have this many resources. I'm going to solve X, Y, Z as a problem. Now you need to analyze the problem and get your requirements well in line. You need to design a possible solution there, and then you implement it, which is the actual raw programming part of it. Then you need to test the solution. There's an integration part that you can see here, is that sometimes you have multiple solutions you need to implement to solve the problem. So different modules in a program, and then you integrate them. That's in your testing phase as well. And you see how they behave together. And then once you've done that integration part of it, you need to deploy and maintain. So that's how you release the program. Typically, as a user, you must have seen when you've installed a new program, that's a deployment. Once you get an update on that, that's a deployment of an update. So there's a maintenance phase that goes into any program. You need to make sure that it works well, that if your users have a problem, you help them out, you fix the bugs and all those things. And this is an iterative process. Maintenance leads to issues to fix, leads to enhancements. When you get the feedback from your users, you create new requirements, and then you start the cycle again. You have to plan for how you're going to fix these, how you're going to implement these, and the entire process starts again. This is why it's a circle, it's not a straight line. And this process, as you can see, is very logical. The steps are simple. And the interesting thing is you can solve any problem with it, although, software development is what this diagram is about. But with this, you're basically an inventor. So congratulations on that. There's a lot now you can do just based on these steps easily. You can do that in any domain. Now, before we proceed, it's important to note that this might seem complex and you might feel that, hey, this is not for me. I'd just like to remind you that programming is a very inclusive field. Just look at the people on this deck right now. The very first programmer was Lady Ada Lovelace in 1843. Now, 19th century nobility women, typically you would not associate them with having a classical job. And here you go, a woman was the first programmer. That's already pretty indicative of how inclusive the field is. Now, look at NASA's software development team, for landing astronauts on the moon. The lead there was, again, a woman, Margaret Hamilton. And we're talking about the 60s, the 1960s here. The status of women at that time was very different from what it is today, much more restrictive. And again, look at what her team accomplished there. These dictionary-sized, these encyclopedia-sized books, actually, are all the code they've written. Now, the person who invented pausing in video games, like video games are a topic very close to my heart. So in the 1970s, the status of people of color was very, very different. And still, this person got a job, got this implemented, and changed people's lives, right? So now when your mother's telling you, hey, go have dinner or go do your homework, you have the possibility to pause your game normally. So you have this person to thank for that. And all the women before who actually got programming to where it is today as well. Now, the important thing is that this is a technical field. So a good programmer will be judged by the competence and quality of their code. How society perceives them doesn't really matter there. Previously computer nerds were thought of very, very poorly. You think these are people who smell, who don't have social skills, all those kinds of things. But now, these very same nerds are in charge of the world's most valuable and powerful companies worth billions and billions of dollars. They influence everything you do today. So this is basically a field that doesn't reject people. If you're good at it, you'll be rewarded. Another thing as well is that the work that you do, a program, can live on well beyond you. In fact, some very old mainframe code, these mainframes are huge computers. They've been running since well over 50 years. So, your work has value, it has impact. All right. So don't feel rejected. This is a very, very inclusive field. Now, what do you write programs in? These things change. Okay, programming languages evolve over time. Some things become more popular, some things less. As of 2022, this is the latest ranking. As you can see, there's a site called the IOB Index. As of May 2022, Python is currently the most popular programming language according to this index. The C used to dominate this chart for several years, so Python recently became more popular. There are other programming languages like C++, Java, JavaScript, and C# and SQL, which are in the top 10, as you can see here. These are staples of programming. If you want to learn a language, look at the field you want to learn to build solutions for, and then choose language there. But this list here will get you started on just about anything. They're very general purpose. They work just about everywhere. But whatever you do, focus on doing the basics right first. Get your base concepts right. Practice with some practice exercises and projects, and then proceed. Otherwise, if you don't get the basics right, you will create a mess that you will need to fix, and that others who depend on your code will need to fix. So please get this right. Now, to get started on this, again, as I told you, to get the basics right, there's a fun little exercise called Hour of Code. You can just go there and learn about programming there, hourofcode.com. Within 1 hour, you get a few exercises, and then you can explore tutorials for various languages. All right. Let's move on to AI now. So artificial intelligence, as defined by the Encyclopedia Britannica, is the ability of a computer or a robot controlled by a computer to do tasks that are usually done by humans because they require human intelligence and discernment. This is a very long-winded way of saying making a computer or a robot do what a human would typically do, right? But it's important to note that AI today is not general purpose yet. What does general purpose AI mean? Whenever you see a science fiction robot or like a software who has feelings and things like that, right, in a movie, we're not there yet. It looks like we might be there yet. You can talk to your chatbot and all that kind of stuff, right? But it's not truly intelligent. When Siri says it loves you, it's not true. It's lying to you. Okay, sorry if I broke your heart on that, but right now these are just facsimiles. Okay, they don't have true intelligence. It's a limited pattern recognition and generation system. So it sees the pattern. Hey, look, if a user asks, book a flight for me. Okay, so that pattern means, okay, I need to connect to a service that can book a flight. I need to send it some parameters saying, okay, this date, that destination, this airline, I'm going to book. So it recognizes the pattern, it acts upon it based on a program, and then it generates a pattern back, which is translated into a voice to respond to you. So it's not true intelligence as of today. However, despite these limits, what we have built in AI today is still very useful. The results are already world-shaking. Like some AI has begun to replace jobs today. It can do some rudimentary analysis on patterns and tell you, hey, okay, this trend in my data is indicating that the market today is going to shift more towards certain companies than others. Right now, it's more about augmenting humans rather than replacing humans, but there are cases where it has started replacing humans. So what is important is that as long as the human gets good at what they do, the AI won't be able to replace it. So I would sincerely advise everyone, please focus on your studies. Don't just do the bare minimum. Get good at what you do so AIs don't replace you, or at the very least, get into AI and programming so you can write the AI yourself. All right. So now, even with all the limitations we've talked about right now, AI today is very, very powerful. It's changed the world. You can create all kinds of things with it. You can generate art. You can generate deep fakes, which they use for special effects to replace actors in movies, to de-age them and that type of stuff, and even bring back dead actors on screen, right? These are things some of you might have seen already. But the ethics around this, the laws around this, the societal norms around this haven't caught up to these applications yet. Most people are not even aware that what AI can do today, the depths of it, the impact of it, how harmful it can be, and what types of restrictions we need to place on it for it not to cause problems, such as in autonomous weapon systems, which are deployed with very limited oversight today. You need human rights to protect people from those types of applications. So whatever you do in this field, please bear in mind the ethics of what you're doing. The laws may not have caught up, but you have a responsibility for what you build in anything that you do. All right, so let's move on to the next thing here. This is about the industry of AI, the top 10 AI applications by market value. This dates back to 2020. More recent stats were a bit more problematic to compile, but this still gives a good idea. Today it's about the same. It ranges from medicine to manufacturing to fraud detection. So it's finance, general automation, cybersecurity, image analysis, and getting the Internet of Things, things like home automation control, connected machines, all those types of things, getting those together. The smallest number on this slide is $2 billion. The largest is $40 billion. So if the smallest is 2, that already gives you an idea that how valuable these solutions are. That was 2 years ago. They've become more valuable now. So AI does a lot of very, very valuable things. I'm not talking in the air here. These are real life numbers. And these applications keep growing. AI keeps learning, right? It's a limited form of intelligence. So it can do more and more over time. Now, let's look at one of those things. So it's possible that over the call, the animation here may be a bit janky. I apologize for that if that's the case. But as you can see, image recognition in real life already exists. Self-driving cars, fully self-driving cars don't really exist right now, but limited self-driving does. And how does the car know how to drive? It needs to detect objects, right? So as you can see here, it's tagging objects like cars and people and traffic lights with a probability of how sure it is. And based on that, it's taking decisions. And this is image processing as classification. It's a type of AI operation. It's doing it in real time. Now, as you can see here, these are very impressive results. It's fairly sure, it's tagging things really well. And that's the state of the art today. This is actually pretty useful, pretty good as it stands, right? Now, how exactly do we implement that? There is an approach called machine learning. Most AI tasks today involve machine learning. And there are many types of machine learning and many techniques available. You can go through the deck here just to get some idea, but machine learning can be supervised. You need a human to help the program learn. Unsupervised, you have a learning program that can do it on its own, detect patterns from the data. And reinforcement learning, the program learns through trial and error, basically similar to biological systems. And there are many techniques. Artificial neural networks are the most promising here, as this lady is helpfully pointing out. We have systems like decision trees, support vector machines, Bayesian networks. Don't worry about how complicated this sounds. These things have already solutions available in the wild, and you can build upon them. Now, if we look at the general steps of solving a problem using AI, you need to get your data. The right data is extremely important. If it's missing things, your program won't know what to learn. It's just like in school, you need to have the right notes and the right exercises to learn. So the program needs to have that as well, right? You need to analyze the data to identify the trends and determine possible features that your AI would need to identify and use. You need to build and train your model. So you select a technique. You've seen there are many techniques around. You need to select one that fits your domain and your problem. And then you build your model. You use the various techniques, connect them together and train on that data. And then you need to evaluate and tweak that model. So that's actually the hardest part out of this. Your results initially with AI may not be perfect. It's a bit of an art and a science. So using various metrics, these are indicators of accuracy, for example. You need to evaluate your model and see if it fits. If it doesn't, you need to train it maybe with more data or tweak how you trained your model, and until the results are acceptable. So it's an iterative process. Okay. So if you want to build your AI model, you need to be very careful about the approach that you use. You need to research which AI solution on the market right now might fit, and based on the problem you want to solve. And then you need to experiment and adapt. So as I said, it's a mix of art and science. Whatever you chose initially may not work that well. So you need to adapt to your findings, what your findings are telling you, and find something else and try again, or tweak what you have today. All right, the typical tools you would use, you can do it on the cloud or on your computer. But in both cases, Python is pretty handy for that. It's the workhorse language for AI. Machine learning tasks are packaged in something called a Jupyter Notebook format. You'll find that typically online. But real life solutions do use a mix of both, C++, R, and Python sometimes for powering very large scale solutions. But Python, if you're practicing and experimenting on your own, that should be a good starting point. If you're doing this on the cloud, you have platforms like Google Colab and Microsoft Azure. Google Colab is free. It's great for experimentation and trial and error. Microsoft Azure is paid. As students, you might have some discounts though, if you want to try it out. On your computer, you can install something called Anaconda. It's a software environment for Python, machine learning, and data science development. The hardware you would need, based on your workload, you might need a fast multi-threaded CPU and definitely a powerful GPU. GPUs are not just good for games. They're great for AI, and they're used by major companies right now. So these are some of the tools you would need. And an overview on this very rapidly evolving and large field. So thanks for following along. If you want to reach out, these are the links for me. And yeah, let's go over the questions.
Well, thank you, Mr. Seebun, for your presentation. Indeed, very interesting. I'm just wondering what can we expect from AI in the future?
Right. So AI today is, as I said, very limited. It's pattern recognitions, question and answer systems. It's very likely that in the future we would have much deeper forms of intelligence associated with it, and tasks that are surprisingly going to be taken over by AI. Things like, the robot phone calls that we have today are very much in danger, I would say. Things like service center calls, those types of things. Those jobs are definitely things that AI will be getting very good at in the future. But also things like predicting, governing things. The previous presentation was about disaster management. Identifying those risks faster in real time, augmenting people's decision-making capabilities with real-time analysis, and really going much more in depth with data, connecting various domains together, connecting people across the globe, like real-time translation in a much more deeper way. And those types of use cases, fundamentally increasing the capabilities of people in their day-to-day lives and at very high levels of both government and companies. These are things I see happening the next 5 to 10 years quite easily.
Well, let's see if we have any questions from our participants.
I can see Teja Dalu has her hand raised. Maybe she has a question.
Okay. So, no. Anyway. So, okay, I don't think we have any questions, but anyway, well, thank you, Mr. Seebun, for your presentation today. And indeed, if there are any questions occurring afterwards, we'll just forward it to you on your contact details.
All right, thank you very much. Have a great day, everyone.
Okay. Well, have a nice day, and bye.